Let's look at the idea of maximums and minimums. We have two different kinds. We have local max and mins, and we also have absolute maxes and mins. Let's first look at local maxes and mins. When we look at the local maximum, what we're trying to see here is, just as the word implies, the maximum. If you have any kind of value of x, let's call any of these x, right? Any of them can be x. They all are going to have some kind of f of x value. So you have some f of x, some y value that exists. And just within some area, let's call this area like the open interval I. And this may be from like 1 to 7 or -3 to -3 to like 0, whatever it may be. You have all your values of x that exist within this interval. But then at some point, there's going to be some value c such that its y value, f of c, is going to be the largest. It's going to be greater than all the other f of x values. This point right here is what we call our local maximum. So as we can see in our definition, the local max occurs at C within some open interval I, where C is not all the same values as the x values, and where we see that the f of C value is greater than all other f of x values just within the area. Okay, so we're talking about just some small area, which we can call, or interval rather, interval would be a better word, some small interval I. That's why we use the word local, because it's just within a particular vicinity. So within that area, where is our largest value? On the flip end, likewise, we can also say the local minimum is going to be the other way around, where if you if you have a particular graph and you've got all these x values that exist here, then at some point you're going to reach some lowest value within some interval, and this lowest value, again, we'll call f of c. But this time, that f of c value is going to be smaller than all the other f of x values, and that's what we call a local min. When we think about local, you're just thinking about within a certain small area. Think of like a community, a very small subset of your entire graph. Okay? So as we take a look at the graph for number 4, there it is, it got displayed now. Oh, I guess it only displayed, there we go. So if we take a look at number 4, let's find the local max, and let's also find the local min. Okay. Now the difference between A and B is that in A it says, at what numbers does f have a local max? Well, if you look at our graph, our local max again is where our graph kind of has like a hump, like a hill, right? And it's going to be like the tallest point. So if we look at this graph here, we can see that the local max, just within some interval, let's call this the open interval, we have a local max that occurs right there. Whenever you get that hump, that's where you get that local max. And so we can see at what number does it have a local max? Well, that occurs at the x value of 1. So that's when it occurs. A is asking when it occurs. The difference between A and B is now B is asking what is the local max? The local max is actually the y value. Where does it occur is asking what the x value is, and what is the local max is asking what the y value is. So in this case, our y value is 2. Okay. Likewise for C, at what number does f have a local minimum? If we look at our graph, just like maximums were like hills at humps, then at minimums we're looking for that lowest point, right? Like a dip. Okay, so we want to find that lowest point, and the lowest point, if we take a look here, it actually occurs twice. We can see a local minimum occurring here and another local minimum occurring here. Okay, so at what numbers does this occur? When does this occur? It occurs when x is -1 and also when x is 3. What are the local mins? Well, let's look at the y values. When x is -1, the y value is 1. When x is 3, the y value is 0. So those are our local mins. Let's take a look at absolutes now. On the next page here, we have the definition of absolute maximums and minimums. So the difference between absolute max and mins is that there is actually only going to have one or none absolute maximums or minimums. Absolute means kind of like total, right? So we're looking for, in an entire graph, Do you even have like a highest point? This is like the maximum, the highest maximum, or the lowest minimum. So when we're looking for absolutes, we want to find like the lowest point. So you can't have more than one lowest point. There can only be the lowest point. Okay, so in terms of our definition, we're going to let f be that function again on some interval I, and there's going to be a number u in there where it will give us the absolutes. Now, in order for us to have that absolute maximum, our u value needs to be greater than x. Okay? Or we can say that it occurs at the value of u. Oh, sorry. I meant to say f of u is greater than f of x for all x in I. Okay? Now, same thing for minimum. If we want to find that lowest point, what we're saying is that if that occurs at some v value, then the f of v value is going to be smaller than all other f of x values. And the minimum occurs at the value of v. Okay? Let's do one of these examples together, and then you'll do the rest on your own. Let's take a look at our first graph here. If we want to find the absolute maximum and absolute minimum, let's think about, remember how absolute max is the highest point possible on this graph. Well, as we go from left to right, we notice that the graph starts here at this point, negative 2, 1, and it keeps getting higher and higher. This is not an absolute maximum. It's not even a maximum at all because the graph keeps getting higher and higher. Oh, look, here we have a maximum. Okay? In fact, this is a local maximum because within some area, this is the highest point. Okay? So we have a local max here. The question here is this local max also an absolute max? Well, as we keep going along the graph, now we're getting lower and lower. This graph is getting less and less. So, okay, it is possible that this becomes an absolute max. We keep going higher and higher. Now, one important thing to notice here is the graph does show an arrow right here, which means that this graph keeps going on and on and on, right? Because it goes on and on, as we go further and further to the right, we actually don't have a maximum occurring over here because whatever point you choose, there's always going to be something higher just a little bit more to the right. There's always going to be something a little bit higher, a little bit more to the right. And so for that reason, if this keeps going up and up, you're not actually going to have an absolute max. There is no absolute max in this problem. We have a local max. The local max occurs at 0, 5, but there is no absolute maximum. Okay? Let's look at now the absolute minimum. The absolute minimum is the lowest point of the graph. Now, unlike the absolute maximum, do you see a lowest point on the graph? Well, you do. You have a couple low points. Do you think the absolute minimum is going to be here? Or is there something lower? Hopefully you see that something lower is going to occur right here, right at 4, 0. So the absolute minimum occurs at x equals 4, and the absolute minimum is the value of 0, y equals 0. Okay, so that's our absolute min. Okay, go ahead and do the other 3 on your own.